Today we're talking about distributing a monomial to a polynomial. So make sure you get your date, your page number, and your learning target down, and you put all this stuff in your table of contents. I want you to remember back to the word monomial. We've talked about that. We talked about that in the last lesson. Monomial means one term. So basically you're taking one term and you're distributing it to all the rest of them. So before we get started with that, you had a couple questions to answer on your educating, and hopefully it'll make sense that when you combine, just like we did adding and subtracting polynomials or any kind of monomial, it's just combining like terms. So in number 1, that's adding and subtracting. So you're combining like terms, and the only two terms that are like are the ones with the same exponent. So I can only add 3x squared to a negative or a minus 6x squared, which gives me negative 3x squared. And then I would bring down the 5x to the third. Now, we want to get in the habit of writing it in standard form, which means biggest exponent to smallest exponent. So I would need to rewrite that as 5x to the third minus 3x squared. So all you're doing is combining like terms. Now, when you look at this one, this is a multiplication symbol, not addition and subtraction. So if you remember back to your order of operations, there aren't any parentheses, there aren't any exponents, but I do have multiplication, and that comes before adding and subtracting. So what I'm going to do is I'm going to multiply these two terms together. Well, think back to your multiplication rules of exponents. Remember, you multiply these coefficients to get 15, and you add the exponents. If I have 2 x's here being multiplied together times 3 more, that would give me 5 x's multiplied together total. So when I did this step, the multiplication step only, I would get this. And then I haven't done anything with the minus 6x squared, so I'm just bringing it down. Now that that's there, if I can, I will combine like terms, and I cannot because this is an x to the 5th and this is an x squared, so that is my final answer. So we're going to use what we just did in this opening activity to distribute monomials or one term to a whole bunch of different terms. Okay, so when you multiply polynomials by a monomial, you distribute the monomial to each term inside the parentheses. So example 1. First thing I'm going to do is I'm going to multiply 4x, and I'm going to multiply it times everything in here. So I got to think back to my exponent rules. 4 times 3 is 12. And then x to the 1 times x squared gives me 3 x's multiplied together, which is an x to the third. So that was this first term. The second term, 4x times a positive 5x gives me a positive 20. And then x times x would give me a 20x squared. And then the last term, 4x times this 2. 4 times 2 is 8, and they were both positive. And I only had one x in the problem, so it just makes it a plus 8x. Now I would check and see, can I combine like terms, and I cannot, because these all have different exponents. So this is my final answer. Let's try one more. Looks a little more complicated, but it's the same concept. It's just got more variables in it. So this is one term because it's not separated by a plus or minus. So this is still a monomial. This monomial is getting multiplied times everything in here. So let's start with this term. Negative 5 times 6 is a negative 30. X to the third times x squared is an x to the 5th. And the only y's I had in the problem were y squared, so they just come down. And that makes all one new term, multiplying those two things together. Now let's go to the second term. Negative 5 times positive 3 is a negative 15. Then I have x to the third times x to the 1, which is an x to the 4. Then I have a y squared times y to the 1, which is a y to the third. The last term, negative 5x to the third y squared times negative 5y squared. Well, I got negative 5 times negative 5, which gives me a positive 25. And then the only x's I had was the x to the third in the first monomial. And then I have a y squared times y squared, which is a y to the 4. Let's see if I can combine like terms. No, this is an x to the fifth, y to the second. I don't have any more of those. I don't have any more x to the fourth, y to the thirds. And I don't have any more x to the third, y to the fourth. These are different. See, this has the x to the fourth power and the x to the third power. That makes those different. So this is my final answer, and it is in standard form because the degree of each term is actually 7, so it doesn't matter which order you write any of those terms in.